So hello and welcome back guys. This is Alan here to teach you C++. So in last time I have told you that we are going to learn like some different operators like the rational operators and logical operators. Let's see about those in this tutorial. So let's get started. Now we start with this operator if. Now let's start with the relational operators. Relational operators, which means it's first of all declare variables. It's your choice if you want to declare or you don't have to declare. Let's give like this. You can straight away write the numbers or you can declare the integers. So yeah, now let's give A is bigger than B. If this statement is true, it would show number A is larger than B. So shows like that. So what does it mean? That is, if the number A is bigger than B, it will show this. So let's try. Now let's change it this side. That is opposite to this. That is, if B is bigger than A, it will show this. And we have to write else if you want to write multiple. Now let's give this. That is, if A is also equal to B. We have learned about this in last class itself, but still I'll teach you. If A, value of A is equal to B, then show this statement. Oh, forgot to change this. Equal to B. That's it. Now declare else. The numbers are invalid. Yeah, that's how we have to do. So let's try it. It's compiling. Execute it. Now number B is larger than A. That's correct. So B is 6. It's bigger than A, that is 5. So let's change the value of this. If it's 7, what happens? Gives A is larger than B. Yeah. Now what if we give same 6? Yes, you know what will be the answer. A is equal to B. Yep. Now you could even include something like this equal to again, not for this. Execute it. It will show number A is larger than B. It means if the value A is larger or even equal to B, it will show this. That is this. And if you put the same here also, it will show the same. Yeah, because it won't show both the statements. Because the reason is the first statement is itself correct. So it will break the statement here and just leave all these. So what comes first has the priority. So that's how these are the relational operators. Now let's move on to the logical operators. That is, let's take this all. We want to change it to the ampersand. Why are we using this? Let me show you that. Fine, okay. Let's give both the values are non-zero. So from the statement itself you can understand, it will check if these both are these are non-zero. If they are not zero, if they are zeros, it will show the statement as false. That is, we have to write else statement for this. Write its, oh sorry, I don't know what happened. False, yeah. Show like this. Now let's see how does it work. Show both the values are non-zero, but if we give 0 for this, so it's false. Now what if you put these? So these two lines means if A is 0, if one of the following is 0, that is one of the values are non-zero, which means that if we use this, if any of these or numbers are non-zero, that here 6 is non-zero, to show this. Here it is, at least one of the following are non-zeros. Now if I change this one also to 0, show it's false. Yeah. So, and there's a last one for the logical operators, that is the reverse logical operator. Is you have to use the exclamatory mark. So this means the opposite of this. Now for the answer for this is false, but it will show the first thing, that is, it's called the not statement. Like if both of these if any of these values are non-zeros, like if we give 6 for this, now it should show this one, but it will show it's false. See, show it's false. And if you put 0, at least one of these should be non-zero to show this. Both are 0, so it should show false, but it will show at least one of the values are non-zero. That's it. So this means it will show the opposite of the value for this. Like let's give ampersand for here. Let's try this.